Today's lesson is on classification of matter. And yes, I've got my handsome Captain Jack Sparrow hat on today. Matter. Matter is anything that is stuff. Anything that has mass and takes up space. And it is made of particles called atoms and molecules. Pure substances are made of all one type of particle. So all H2O, all O2, all AU atoms. Here's some pictures of elements. Notice all the elements in the gold, all the atoms in the gold. Yep. Didn't want to do that. Oh, come on. All the atoms in the gold are the same. So this is a pure substance. All the atoms in the hydrogen are the atoms are all the same, as well as they are paired together as molecules. So these are both examples of elements. All right? A pure substance also can be a compound. And you can see over here on the right-hand side, it's not a great picture, but these are all compounds, different types of compounds. Compounds, again, are going to look the same. You're going to have all H2O particles. Here's another example of a compound. They're all the same. They're two or more different atoms. Notice they're different than these guys. These guys are both the same atom, so this is an element. This is a compound. All of these are pure substances. Elements and compounds fall into the pure substance category. If it's not an element or a compound, then it's a mixture. Mixtures are not pure substances. Now, in order to define mixture versus pure substances, we need to understand what physical properties are. A physical property is something that describes matter. For instance, phase change. Okay? Certain things boil at certain temperatures. Water boils at 100 degrees Celsius. Alcohols boil at about 70 degrees Celsius. So if you have a mixture of alcohol and water in your still and you're making moonshine and you begin to boil it, the alcohol will boil first. And you collect that, and that's what you sell to your moonshine customers. Okay? If you have different types of gasolines, you've been to the gas station and you've seen they talk about octane. Octane is a type of hexane that has 8 carbons in it. Different types of gasolines have different hydrocarbons in them, and they all are going to boil at a different rate. So you can separate those by boiling them and keeping track of what the temperature is as you're boiling them. Other physical properties, phase change. We just talked about phase change. We talked about boiling. Let's talk about freezing. Freezing is a phase change. Okay, things freeze at certain temperatures. Melting, same temperature as freezing point. Condensation, also same temperature as the boiling point. Density is the amount of matter packed into a small substance. So imagine that I have a sponge and I squeeze that sponge together. It's still got the same amount of matter, but now it's taking up a lot smaller space, so therefore it is more dense. Size, of course, we understand. Shape, we understand. If we have any changes to either the physical change, the phase change, in other words, if we change from a liquid to a gas, it's still a physical property. It still has that same boiling point. Density is not going to change, although with temperatures it actually can. Size and shape, unless you cut them, they're not going to change. Chemical properties include how the substance reacts, flammability, the ability to corrode, and whether it reacts violently or not. A chemical change means there is a new substance that is formed with new properties. And this would describe what happens when you form a compound. Okay? So, chemical properties describe a chemical reaction if you have a compound breaking into elements or elements forming into a compound. Mixtures do not deal with chemical changes. They're only physically combined. Okay, in this picture with the different golds, I could get into this gold and physically pluck out those coppers. Excuse me. and they would be separated. Okay? Again, copper is going to melt at a different temperature than gold. So we could melt the whole thing and figure out what we have. It's going to boil at a different temperature as well. These can be physically separated, so there's no chemical change. The methods of separating a mixture, we can use distillation. Distillation uses different boiling points to cause one part of a mixture to boil away and the other remain. Okay, I was talking about moonshine earlier. A still is something that you have a fire over. If you were making moonshine, you would take whatever your grain was and you would add yeast to it. And the yeast would eat all the sugar in there and it would pee out the alcohol. Okay, so if you have a mixture of alcohol and water, as you begin to heat the water or heat the mixture, the alcohol has a lower boiling point, so the alcohol will boil off first. I drew that like a water molecule. Depending on what the alcohol is, it may have multiple atoms. So I'm just going to draw them as little ovals. Okay, that alcohol will boil off, and then you have at the other end a cooling area, and it will reform into that liquid. This is a scene from the movie The Great Escape. I don't know how well this is going to turn out, so we're going to find out. These are the 3 Americans who are in the prison camp, and they've taken all the potatoes in camp, and they are making moonshine. This is their still, and they're about to get a drop of alcohol out of it. This is not a great picture. I'm going to see if I can find a better picture of this. Now they're going to taste it. And then they make it and give it to the whole camp. Alright. Make that go away. Go back to our... So that's a still, and they're collecting alcohol. If you've ever seen the TV show MASH, or the movie MASH, they were doing the same thing. Another way you can separate particles is through filtration. You can use a filter or filter paper, make a little cone out of it, put it into a funnel, and that's exactly what we're going to do this week for our lab. Okay. Well-mixed mixtures. If you have a well-mixed mixture, it's a homogeneous mixture, and I am sure that the minute you hear the prefix homo, that what you think of is homogenized milk. Homogenized milk is milk that is so well shaken you can't see any differences. Milk that comes out of the cow looks like this. Notice the cream has risen to the top. That's where you get the term cream of the crop. The cream has risen to the top, and we skim the cream off, and then what's left is the skim milk because we have skimmed the cream off. Or we can leave 2% milk fat and leave 2% of the cream, and then we shake it up really, really well, and it breaks up all those fat globules, and they get separated throughout the whole mixture. So homo means the same. Homogenized milk is milk that looks the same throughout. Heterogeneous means different. Heterogeneous, you're not going to see the same thing throughout. So if you're talking about milk, you'll see the cream at the top. Okay. Here is a drawing, a particulate drawing. These are particles. A homogeneous mixture, we have compound here, an element, and there are 2 elements that are mixed together, and they are not separating out. They are well mixed. It's kind of close up, so it doesn't work real well, but you get the idea. A heterogeneous mixture here, you would have a definite difference, and you can see differences. Basically, in our case, if it's transparent, we're going to consider it homogeneous, and if it's not transparent, heterogeneous for most solutions. All right, there you go.